Good afternoon. So let us see the geometrical interpretation of the scalar product of the three vectors a bar, b bar and c bar. It is observed that the scalar product that we evaluate of the three given vectors a bar, b bar and c bar represents the volume of the parallel pipette whose adjacent edges are represented by the three given vectors. So here we have the three vectors a bar, b bar and c bar. These three vectors start from the common point say O. All the three vectors originate from the point O. And if it is so, then we can complete the parallel pivot like this with the three vectors a bar, b bar and c bar as the three adjacent edges. Now, in this parallel pivot, the parallelogram OPQR represents the base of this parallel pivot, and if we draw the projection from the end point of a bar on b bar cross c bar, then this represents the height of the parallel pivot h. If we take the cross product of the vectors b bar and c bar, this cross product or this vector b bar cross c bar will be perpendicular to the plane of b bar and c bar. So the vector b bar cross c bar is shown perpendicular to the plane OPQR. And then if we take the dot product of a bar with b bar cross c bar, this is nothing but the scalar triple product of these three vectors a bar, b bar and c bar. As we know that this dot product is expressed as the product of the magnitudes of the two vectors and cosine of the angle between them. So here, if we consider that theta is the angle between the vector a bar and b bar cross c bar, then the scalar product of these three vectors can be expressed as the product of magnitude of the first vector in the product, that is a bar, multiplied by magnitude of the second vector in the product, that is b bar cross c bar, magnitude of b bar cross c bar, multiplied by cosine of the angle between these two vectors. So here theta is the angle between a bar and b bar cross c bar. So the scalar product of these three vectors is expressed like this: mod a bar into modulus of b bar cross c bar into cosine of the angle theta between them. So as we know that the modulus of the cross product of two vectors represents the area of the parallelogram formed by the two vectors as the two adjacent edges. So this modulus of b bar cross c bar into mod a bar cos theta. So this is equal to area of parallelogram OPQR. Modulus of b bar cross c bar is nothing but the area of this parallelogram multiplied by what is a cos theta? A cos theta is nothing but the component of a bar in the direction of b bar cross c bar. This is nothing but the height h of the parallelogram. So area of the parallelogram multiplied by height h. So this is a cos theta is h. And what is this parallelogram OPQR? This parallelogram OPQR, area of the parallelogram OPQR forms the base of parallel pivot, and there is base area of the parallel pivot multiplied by height h of the parallel pivot, and the product of base of the parallelogram multiplied by its height gives the volume of parallel pivot. With three vectors as adjacent faces. So the scalar product of the three vectors a bar, b bar and c bar represents the volume of the parallel pivot formed by the three given vectors as the three adjacent edges. So that is the geometrical interpretation of the scalar triple product of the three vectors. So we can comment here as the first comment we can state here is that the scalar triple product of the vectors a bar, b bar and c bar represents the volume of a parallel pivot formed by the three vectors as the three adjacent edges. The second comment we can put here is that it is not necessary that we should consider only the parallelogram OPQR as the base of this parallel pivot and this has the height of the parallel pivot. But out of all these six faces of the parallel pivot, any one face of the parallel pivot can be considered as the base and the remaining side can be treated as the height of the parallel pivot. So that the volume of this parallel pivot as well can be given in other form as b bar dot c bar cross a bar. Again it is same as c bar dot a bar cross b bar. So this is how we can express the scalar triple product of the three vectors by maintaining the order of the vectors. So if the order of the vectors is maintained, then we can get the same scalar triple product. And all these three scalar triple products will represent the volume of the same parallel pivot. The only change is that in the first scalar triple product, the plane formed by b bar and c bar is treated as base and the other direction is taken as the height of the parallel pivot. In this scalar triple product, the plane of c bar and a bar is taken as the base and the direction perpendicular to it is taken as the height. And in this third scalar triple product, the plane of a bar and b bar is treated as the base of the parallel pivot and the direction perpendicular to this plane is taken as the height of the parallel pivot. So out of these six faces of the parallel pivot, we can treat any one as the base and the perpendicular direction can be treated as the height of the parallel pivot. So that all these three scalar triple products results into the same result. So that is the second interpretation that we can draw from this scalar triple product. And the third one and the last interpretation that we can draw here is that while discussing the characteristics or the laws obeyed by the scalar triple product, we have seen that if the three vectors are coplanar, then the scalar triple product of such three vectors which are coplanar works out to be equal to 0. That we can easily understood from this geometrical interpretation. So here, if all these three vectors lie in the same plane, naturally what will happen is that the height of the parallelepiped will be equal to 0. And if the height of the parallelepiped is equal to 0, naturally the volume of this parallelepiped will be equal to 0. So, if A bar, B bar and C bar are coplanar, then height of parallelepiped will be 0, implying that the scalar product, the volume of parallelepiped will be equal to 0. So if all the three vectors are coplanar, then the volume of this parallelepiped will be equal to 0, so that the scalar triple product of such three coplanar vectors will be equal to 0. So that is the geometrical interpretation of the scalar triple product. So with that we will close it here for today, and next video will continue with the factor triple product. Thank you.